Hello, everybody. I appreciate you coming online to listen to my presentation. I'm going to be talking about mapping the underground, as Gavin mentioned. My goal in this presentation is actually tie in some of the previous presentations, a lot of the technologies that have been mentioned, and even some of the business practices, even what Rob was discussing with CDOT. So I'll be going over not only the state of the industry and some of the issues that the industry is facing today. I'm going to talk a little bit about some of the new technologies that are available, and also what I see that's coming in the next couple of years. So maybe a little glimpse into the future. So with that said, I'll just jump right into my presentation here. So when I talked to Mark initially about the topic mapping the underground, you know, when it comes to this whole concept of smart cities where people are focusing on, you know, drones, power grids, we're talking about autonomous vehicles and buses and AI. When it comes to smart cities, I think you also have to be really smart, if you will, on what's buried below the ground, as opposed to focus on what's just above ground. So what I'm going to be talking here when I'm talking about mapping the underground, I'm specifically talking about the utilities that are buried below the ground. So if we take a look just real quick at what we call our surface infrastructure, that's a vast network of the roads, bridges, and highways that crisscross our nation. And chances are, you know, we use that every day, either for our daily commutes, as I mentioned in here, we take trips to the grocery store, or we're transporting our kids. This network is critical to supporting our businesses, our industries, but also as well as transporting goods to market. It's a well-known fact that this infrastructure is becoming dilapidated. We hear it on the news, we hear it on TV, and of course we experience it. A lot of times it's a nuisance when we hit a pothole or there's some delays on the road because there's some repairs that are being done. And it's estimated right now that it could cost as much as $2 trillion to get that infrastructure up to acceptable levels to meet the current growing demands. So just to give you an idea and to put things into perspective, there's 2.6 million miles of paved roads and highways that of course we rely on for our daily commerce and commuting. Over 50 years ago, that's when most of this infrastructure was actually built. You heard Rob talk about ASCE, the American Society for Civil Engineers. ASCE recently gave a D+ rating to our infrastructure, which is obviously a pretty poor rating for those of us that got grades like that in school. Out of sight, out of mind. So again, a lot of times when we think about smart cities, we're focusing on what's above ground, but very seldomly do we talk about what's below ground. And below the ground, we have oil pipelines, gas pipelines, we have water lines, sewer, we have storm sewers, we've got telephone, fiber optic, electric, cable. So there are a lot of utilities that are buried below the ground that maybe in some cases we're just not aware of because we don't get to see it every day. As far as subsurface infrastructure, there's 35 million miles of underground pipelines and utilities in the United States alone. Most of that is buried below that 2.6 million miles of paved roads. One of the challenges is that the vast majority of that infrastructure was put into the ground over 60 years ago. In fact, most of the nation's water pipes have been in use for almost 100 years. And over on the right, I show you a picture of a water main that ruptured just off Sunset Boulevard in Los Angeles, and the pipe was 93 years old. how many miles of oil and gas pipelines are there? Because in a lot of cases, that's where most of the focus is, because if these lines have a problem or rupture, you're spilling gases into the ground. It affects our environment, and in some cases can cause explosions. So it's very dangerous. But just take a look at some of these numbers. As far as gas distribution, there's over 2 million miles of lines buried in the United States. Gas transmission, 318,000. Hazardous liquid, 200,000. So the total is a little over 2.7 million miles of pipelines that are buried below the ground. Now I just want to go over some annual additions just to show how fast this is growing and expanding. There's 850,000 new houses being added each year. As a result of that, there's 50,000 miles of new gas pipelines that are being built, 250,000 miles of new telecom cables that are going into the ground, and 280,000 miles of new water lines. What might surprise you, and I'll get into this a little later in the presentation, but as these lines are being put into the ground, in most cases, they're not being mapped. So we really don't know where they're going into the ground, at least not with any level of precision. So let's take a look at the problem this is causing. Well, obviously, anytime you add, repair, or replace the surface or subsurface infrastructure, you have a chance of damaging a utility line or a pipeline, and it happens far too often. In fact, just in the United States, there's over 500,000 strikes per year, and that number is growing. That's about a strike every single minute of every working day. And when a strike occurs, what happens? Lights can go out, traffic is disrupted. We've probably experienced maybe some flooding in and around our neighborhoods. But in worst case scenarios, gases get emitted into the air. And far too often, they can be cause of serious injury and sometimes even death. Because I live in Colorado, I can just give you an example, and we can focus on the Firestone incident. And if you live in Colorado, then you're very familiar with it. It was on April 17th of 2017 when a home exploded in Firestone, killing 2 men and leaving a woman and a child in the hospital. Why did the explosion occur? It was due to ignition of a natural gas line that had been severed. So it had been cut. The problem was not knowing the location or the condition of that line. But in that same year, again, we may not be aware of this, we had 9 more similar incidences. So it happens far too often, and it's often a result of not knowing where that utility line is buried in the ground or the condition of it. So what's the current damage prevention procedures and processes that are in place? The speaker before, Rob Martindale, touched a little bit on 811. That process is implemented throughout the United States. So each state has a 811 center. It's called a call center. Utility and pipeline companies provide the location of their assets to the best of their knowledge to the 811 center. And 100% of the construction projects by law have to go out and identify where the utility lines are prior to any type of digging activity before it can occur. These pipelines and utilities are located and marked by locate companies. And when they locate where that utility line is, they put down a paint mark or a flag. But the problem is that there's very little control methods in place or any levels of accuracy as far as how those utilities are located. So let's just take a look at one city, and I'll pick on New York City here and just give you some statistics. So underneath about 6,000 miles of paved roads lies all their utilities and pipelines. And each year, to facilitate construction and repairs, they slice open those roads about 500 times per day. And anytime anybody slices open a road, there's a high probability that you're going to hit a utility line. So they're required to call the call center, 811, to have the locators come out and mark the location of where the underground utilities are located. However, still a strike happens every day and cost the city, they estimate, upward of $300 million every year. So why does this occur? What's the problem? Well, the majority of the problem lies around the fact that utility and pipeline companies have very poor data of where their utilities are located. Often these records are old, they're outdated, they've been lost, or maybe they never existed at all. Any records that do exist are often inconsistent in terms of their quality and their content, and because they're in different data formats, they're very difficult to share with others. So let's just take a look at what these records consist of. What I'm showing you here, and it's similar to what Rob Martindale was showing CDOT, this is a as-built drawing. As-built are design drawings on where the utility is planned to go. But more times than not, once they go out and install the utility, it's not exactly where they planned it to go. A lot of times that might be because they take a path of least resistance. It's not exactly buried below the ground to the depths that are required because no one's really monitoring it. Or in some cases, maybe there's just obstacles like buildings that they didn't know they were there, or the road's been expanded, the sidewalk's been moved, or in some cases, maybe the soil conditions are just too hard. Other times what they do is they'll provide sketches. So this is an actual sketch of a line that's coming out of a house, even though that's not what it exactly looks like. But these are the type of records that go into the system that the next person, either a contractor or somebody that's putting utility in the ground or an excavator, has to rely on this information before they make a dig decision. How is the current utilities located? So when you call into the one call center, as I mentioned, and the one call center determines which utilities could be impacted by the construction, then they send locators out to go out and locate where the utility lines are. So what you see on the left here is that's a radio detection electromagnetic locate tool. And once they locate where the utility is located below the ground, then they'll either mark it with the paint, or in some cases they'll put the flags down, especially if it's in a field or it's in a grass area. Then they'll use the flags. The challenge is that they're not collecting the data. They're only putting paint marks down, or as I mentioned, the flags. So here's an example. You've probably seen this many times. Maybe sometimes you wondered what it was when you were walking out on the street. You see all these markings. Each one of those marks, based on the color and the code, is marking where a utility line is located. When you go out and locate, it's known that that paint mark can be off by as much as 3 feet on either side of the marking. Well, the challenge is that in some of these corridors, especially in very condensed and populated areas, you could have a lot of utility lines within a 6-foot area. So this is just an example of several utility lines that are compacted together. So if the tolerance or the variance can be 3 feet on either side of the marking, you can see how many utility lines you can fit on 3 feet on either side. So what's the solution? Well, this is something that we designed years ago, and as Rob had mentioned in his discussion and his session previously, it's what we call transparent earth and PointMan. But basically what we did is we took the locate tool, and then what we did is we integrated it with mobile device using modern technology, including Bluetooth technology. And then when you integrate that with a precision GPS or GNSS receiver, then what it does is it gives you the ability to capture and record and visualize precisely where that utility is located. So once it's located and captured onto the mobile device, then the person that's out in the field collecting the data can see that he's collecting it, where he's collecting it. He can see the precision at which it's being collected. And then someone in the office can then see in real time on their desktop how that data is being collected. So a little bit about PointMan. So PointMan is just the mobile app that we have developed that will run on any Android or iOS Apple device. And again, is integrated seamlessly in with the EM locate tool. And then you can use any GPS or GNSS receiver. The one I'm showing here is Trimble, but someone actually asked that question at the previous session with Rob is, does PointMan work with other GPS, GNSS applications? And the answer is yes, it's designed to work with any major locate tool and also with any major precision receiver. Once the data is collected, then in real time, it's pushed up to the cloud and it's available on Transparent Earth, which is the desktop application. So it gives and provides the ability that while you're collecting data out in the field, not only can you see it in real time on the mobile device, you can also see it in real time, back in the office. So someone can actually be monitoring it and making sure that it's meeting specific, quality specifications. It also ties into 811. So what that means is that the one-call ticket can then be pushed out into the field onto the mobile device. And while the person is out there collecting the data, he can see the area of the one-call ticket. He can see where he's collecting and locating the utility lines. But also he can create forms so that instead of filling out forms on paper, which is the way that it's done majority of the times today, we can actually create a digital form that's also geo-referenced. And then in the form, to ensure the quality of the locate, we can also take photos to record where the lines were located. We can add any notes that are necessary just using voice to text that's available on the mobile device. And we can also use satellite imagery to provide a sketch of where the lines were located so that we don't have to draw a funny sketch on a piece of paper. So we can go ahead and add photos. And again, we can add sketches and then add any notes that you want to accompany either the photo or the sketch. So let's talk a little bit about what I think is next. So with the current technology that we have available today, and I showed you that we can precisely capture and record and display where these utility lines are, who needs that information the most are the guys out in the field. And that includes the engineering and surveying crews, the construction crews, and also the excavators. So how can we leverage modern technology utilizing the data that's being collected out in the field to not only map what's buried below the ground, but do it in a manner that is far more useful to prevent damages that far too often occur during construction? Well, one of the advancements that I see that we'll be able to utilize is the ability of 3D. And we saw some of that in some previous sessions. So let's show you what I mean by that. So as I talked about, we can locate where the utility lines are. We can capture it on the mobile devices. We can integrate that in with high precision GPS and GNSS receivers to ensure that we're capturing that data, in some cases right down to the centimeter. We can make that information readily available up to the cloud so that we can visualize it on desktop applications. But I think what's next is then we can utilize augmented reality. So for example, this is the Sight Vision device that is developed by Trimble. It's basically a handheld device for augmented reality that has a precision GPS receiver built into it. So what would the applications be for that? Well, on the left, you can see if we collect all of the data utilizing mobile technologies and the EM locate tools and high precision GPS receivers, we then have the data that can be viewed to relocate where these utilities are. So if I'm out on the project, I could actually utilize augmented reality, in this case, the site vision that's provided by Trimble, and I could walk around and actually see precisely where the utilities are located buried below the ground. And depending on where I'm doing any construction and there's going to be groundbreaking activity, I can determine if the information that I have is good enough to avoid any conflicts, or if I have to call another team out to precisely locate where those utility lines are to make sure that I don't hit them. So where do I see this going from there? Well, then I see this going to what I would call excavation guidance systems, where when the excavator is out there and he's digging, then we can also leverage this technology, including augmented reality, to provide the view of where all the utilities are relative not only to where the excavator is, but also where the bucket of the backhoe is. So he can see if there's any potential conflicts he needs to be concerned about. We could also provide warning signals if he's getting within a tolerance zone that's unacceptable with the bucket. The reason I say that is there's an old adage out there in the industry that unfortunately the #1 utility locate tool is still the bucket and the teeth on that bucket, which is unfortunate because when something of that power hits a utility line, you can imagine the damage that it does and the potential consequences as a result. But this is where I see things going, and I see this happening in a relatively short period of time. I think it's just right around the corner because, in fact, all of the technologies are here to provide this. We just have to have companies out there that we would consider, early adopters to go ahead and adopt this technology and test it. But I know companies like Caterpillar and John Deere are working on these technologies. You can see already what's available as far as augmented reality through companies like Trimble. We have the ability to precisely locate and capture and record and display where these utilities are buried below the ground. So we have the wherewithal and all the technologies here to be able to provide this level of mapping the underground and knowing precisely where the utilities are located. So hopefully I just kind of gave you an idea of some of the challenges in the industry, some of the technologies that are being developed now to address those issues, and also what I see as coming in the near future. So with that, I'll pass it back to Gavin, and I'll take any questions that anybody may have.
Thanks, Rob, or thanks, Paige. Sorry about that. Thanks, Paige. Yeah, it was great. You gave a really good overview of what we're facing, especially the idea that even though, like Rob said, there's like statutes and there's rules now and about how to collect with the modern technology and the modern capabilities moving forward. We've got legacies, decades, centuries of unknowns out there in those right-of-ways. So anything that can be used, when somebody does a locate, even if it's not that high precision, as long as it's stated a range of precision, at least it's helping validate or verify some of those printed records that folks are recreating these networks with, for the visualization tools and those navigation tools. So I had a couple of questions and follow on from the last session as well. So you're tying in your tool, the locate tool. So for instance, if somebody's using a GPR though, which could come up with a very precise and also, non-ferrous utilities as well, if they're shallow enough, how hard is that to integrate that data in with say your applications?
So it can be integrated, and in the past we've worked with companies that have developed GPR technology. One of the challenges with GPR is it's obviously dependent on soil conditions, and it also takes someone with a pretty high level of expertise to interpolate the data. But you can integrate the ability to capture, record, and display GPR data, and obviously integrate very high level receivers, GPS and GNSS, to get very precise location information. So yes, it can be done.
Okay, and a bit about the challenges of GNSS challenged environments. Well, right-of-ways are where a lot of trees get planted. So that's our challenge up here in the Pacific Northwest. There's a right-of-way, there's a lot of trees, so GNSS is tough. That's getting better with multi-constellation. I mean, doubling of the satellites, just adding the Galileo and the Beidou in a lot of instances. But integration of the MEMS in these location devices, they work better at speed, of course, like for mobile mapping. But a comment from an attendee in Chile. He says he's quite envious. They're light years behind, he says, down there, and wish they could do that there. Well, that's why these sessions are put on. You get to hear from Rob, who's implementing this, and Paige, who's got the tools.
Well, I was just going to, on that note, Gavin, the technology, for example, we've developed works anywhere in the world.
Yep.
So, and the other thing you mentioned, the question you had, was on areas where you don't have the ability to connect to a receiver. And I want to make note on this because Rob can elaborate on it, but we've been testing receivers that actually you can set up RTK roving. So you have the ability, even where there is canopy, to get down to centimeter precision by utilizing a roving RTK receiver.
Oh, okay. With the multi-constellation, yeah, canopy will always be a bit of a challenge because if you can't see the satellites, that doesn't magically transmitted under the trees.
It doesn't. I'm not an expert on this, but I can bring some experts in where there are receivers that actually, once you have disruption and you do have canopy cover, then you can still receive the accuracy, even though it's disrupted.
Right. This is probably something more for a discussion in the GNSS session. I've been doing GNSS for over 30 years now. I think there's some misconceptions there. With an IMU, you can carry position to some degree for a period of time under the canopy. But right now, there's no magic system that can see through thick canopy.
That's correct. Yeah.
But there's light years of I'd like to talk to you offline about that because there's still limitations, but there's great potential.
And by the way, I should mention, I only know enough to be dangerous. So. Oh,
okay. And probably I'm kind of a crusty old GNSS guy that's going to be too nitpicky about it. But anyhow, I am really like you. I'm really impressed with what's available now. So, questions from user: how accurate would the augmented reality depict the backhoe bucket? Is it to a point where utilities won't have to be marked and excavate with record data, or are we not there yet? I guess the attendee is referring to the geofencing capabilities.
Yeah, we're not there yet, and obviously what that would require is a sensor on the bucket of the backhoe, and that sensor would also have to have a GPS, GNS receiver down to whatever accuracy is required. So if you wanted to get down to be digging within a few inches of a utility line, then the sensor on the backhoe would have to be integrated with a very high level precision receiver, which would also have to be on the backhoe itself. The point I was making is that the technology is here, and we could actually do that. The question is, when do we decide to do it? Who's going to lead it? And then where does the adoption take place? Because you need all of those components. But the technology itself is here.
Absolutely. And, in 4D construction, the machine control what's going on out there in the field is just mind blowing. I visited different sites, and the way that they're rigging up the heavy equipment with the GPS receivers or the prisms for guidance with total stations. There's things about elevation control with a Z-beam, like with the Topcon millimeter system. But I've actually seen examples of the geofencing you're talking about, where they set a limit and that bucket is never going to swing out there. They're integrating GNSS antennas with IMUs as well for grade control. So it's a brave new world. It really is amazing. But
Well,
they're going to require on the accurate mapping that you guys provide, though.
Well, interestingly enough, is that we actually started out building excavation guidance systems. That's why we're ProStar, very similar to OnStar, but ProStar being for professional navigational purposes, as opposed to getting you from point A to point B where you have line of sight. And I worked very closely with John Deere and Caterpillar, and they're the one that brought me the problem and said, where are you going to get the information to load into your excavation guidance system? We said, well, we're going to get it from the utility and pipeline companies. And they said they don't know where their assets are buried below the ground. So that's when we took a step backwards and said, okay, then we're going to design the system that can capture and record and display the data. So we actually made a pivot in our business model. And today that's our focus, is actually capturing the data, measuring the quality and confidence you have in that data. Because at the end of the day, it's this is about data, right? Garbage in, garbage out. Your business decisions are only going to be as good on the confidence that you have in the data that's being provided to you. And that's been our focus.
Excellent. Well, that's it. There's no magic, no geospatial magic and no reality capture without the people to capture that reality and capture it accurately. And on that note, the virtual conference next month is specifically about underground. You can go to the same web page, the assetmapping.events, and there's a link to that. The agenda is filling out rapidly. So on the note that you made about gathering that data, a couple of questions from the users, and Rob might want to chime in. Are there now, or will there be a requirement in the future for municipalities to locate either lost, unrecorded, or outdated utility records, perhaps by contracting out this technology?
I will have Rob answer that, because Colorado is actually one of the first states that is mandating SU quality data collection. And I think what Rob is mandating through CDOT will probably impact municipalities, but I think it's best if he elaborates on that.
Okay.
Yeah, I agree. The legislation is intended to, to impact pretty much everyone as a whole throughout the state, but it's to obtain better records. It's really intended to provide the best available information to start with, and that's where we struggle in Colorado. Is where is our starting point with the records? And we know it's not very good. So our system is planned to help supplement records or be a redundant repository for utilities to tie into our records that we have, share with them. So it's really implemented to share records and become a better records system, because that's where everything starts from. And we recognize it's not a very good place to start in most states, including Colorado.
Okay. A question from Sean C. For Paige, what does the growth look like for ProStar with both their field and office software? What is the type of data? Is this type of data capture growing rapidly, say, outside of Colorado as well?
Yes, it is. In fact, we are now doing business up in Canada. We're working with one of the largest construction companies in North America that has operations not only in North America, but throughout the world. We have other DOTs that have adopted our technology. So like any new technology, it takes adoption because it is a little challenging because people are so accustomed to sticking to their current legacy business practices that to get them to change, sometimes you have to come out with something that is so impactful that it basically pushes them to change. And we're just starting to see that. And so as agencies and large companies start to use our technology and they see the benefits as a result of using the technology and measurable ROI, then I think we'll see much broader adoption throughout other states, North America, and hopefully throughout the world.
Well, I certainly hope to see that in my neck of the woods. We haven't yet. And having to do locates, we have to pothole too much here because our records are, and there's, pretty bad shape and there's no requirements at this time. So I'll talk to you offline about that. A question from Omar. Well, it brings up a good point. He's talking a little bit more specifically about, access to things like the cores for the corrections and the GPS because it's expensive. Maybe I can paraphrase your question, Omar, is about how do you manage it when a contractor or a client or somebody doesn't have that specific equipment? I mean, how do you balance the requirement? They just don't have the gear.
Well, that's probably a question for Rob, because when it comes down to the gear and the precision of the locate of the utility and obviously what requirements it has to meet, then that comes down to the client. So that would be a question for Rob, because we can capture it to any level that the client requires, but the type of equipment you use and the cost of that equipment, that's something obviously that the client is sensitive to. So I'll have Rob answer that question.
Yeah, we recognize that there's equipment challenges. We've been working hard to identify low cost, high accuracy solutions for that, for options to our stakeholders. And so, there's a couple options out there that we can offer or suggest to companies that are lacking the equipment or whatever. And so there's some really good correction services out there that are subscription based. They're even as flexible to allow centimeter correction at just buying a block of time. So you can, if you only need 10 hours, it might only cost you $100 to go out and survey at a higher accuracy with a lower cost, GNSS antenna. I mean, they're down to $350 now for a GNSS antenna. But tying into the correction services, CDOT as a whole has subscriptions to all of these correction services in Colorado. So we're even to a point where we may offer those out for checkout to allow certain folks to use those in certain situations, or we'll offer inspection, some of our internal staff to come out and collect that data. But at a bare minimum, we would accept if a utility doesn't have the ability, they can request in writing to have a less accurate position collected based on their need. So we want to make it flexible enough that we get something out of the as-built, even if it's less accurate. At least we know it's there versus not even knowing at all.
Hey, Rob, that's a good point. I can just elaborate on that real quick. One thing about technology is it accelerates so fast. So, of course, cost is often a barrier. And a lot of these precision GPS, GNSS receivers have, been in excess of, $25,000, $30,000. You have to be trained to use them. So it's very expensive. But you have to remember, it wasn't that long ago that a 70-inch TV cost about $3,000. Now they're $299, or you get one for free if you buy a different item. Well, it's the same thing we're seeing now in these receivers. And I'll just give an example. We're working very closely with Trimble right now, and they've actually come out with a receiver called Catalyst. And that may be what Rob was talking about, is $350 is all it costs. And that will give you survey grade precision. And then what you can do is just buy blocks of time. It's like on demand. So if you only need it for a month, then you can just buy a block of time for a month. So that barrier to entry as far as cost, I see that going away just like other technologies, because location services are becoming so prevalent, even in the global market, that there's all types of companies that are now entering the market, providing these receivers. And obviously, the more competition there is, not only does it drive innovation, but it dramatically reduces the cost. So what used to be a barrier to entry, I see is starting to dissipate now.
Right. Yeah, Dan mentioned about, and there's no endorsement of any product, but as an example, this catalyst that Dan mentioned yesterday, you buy just the antenna, and because it has to do the analog to digital, and your phone's processors are a software-defined receiver. You rent that software receiver on an as-need basis, as Rob was talking about, so you could use credits. So a contractor might only have to use that a few times a year or a few times a month on an as-need basis. So there's a lot of that. The cost of receivers is going down dramatically. There's all kinds of new models that people are recognizing that, sporadic field need for the occasional users. There are the surveyors, we want that thing, the expensive one, to run all the time. So this adaptability is really promising. A comment from Jeff Z. Comment and a quick question. Modern reality capture technology for underground detection is improving rapidly. Yep. Some utilities have decided that recapturing the location of their infrastructure is more efficient than trying to just improve their existing as-builts. Any experience, Paige, with ProStar that has with this sort of approach?
Well, it's an interesting question, because I would call that, the definition of insanity, which be, I would call it one and done. If they were capturing the precise location of the utility as it was being installed into the ground at a level of precision that was, even down to the centimeter, and get it done once and not have to do it again, there would be no need to go out and relocate the utility. Now, we are seeing some companies doing it, but it's a very small percentage. We need to see that on a much larger basis, because then it would address this issue of having to go back out and relocate them. But we're still going to be faced with the fact that we've got 35 million miles of legacy utilities that are in the ground that we don't have data that we can depend on with any level of confidence. But it's a great question. It's a question that we'd have to extend out to the utility owners, which is, why aren't you capturing this data when it's going into the ground? Well, the answer is probably going to be is that it's expensive to do it. And I don't think they understand the return on investment, that if they invested that money today, how much it would save them, in the long run. But again, someone's going to start doing it, because it's becoming much more cost effective and easier to capture that data. So I think we'll see increased as-built data, if you will, being captured as the utilities being installed. I don't know what Rob thinks about that.
I did want to just comment briefly, because CDOT, we consider ourselves a utility owner as well, with our own fiber and electric and other utilities that we have. And we recognize that being able to recapture that data is important, but we found that if we can capture it with an accurate as-built while it's being installed, is one, much more efficient on retracing it or getting back to it when there's a maintenance or a hit. We can just stake it back out with the staking tools within PointMan. But two, if we lose connectivity to the relocating wire or marker ball, whatever it is, over time, sometimes, especially in the soils in Colorado, the signal goes away, or we lose strength in some of the signals, or it's easier for somebody to stake to a line rather than trying to follow a signal and learn how to run the frequencies, and they tend to bleed off on other utilities. So there's a lot of reasons why we think collecting an accurate as-built and having the ability to stake it X, Y, and Z is a much more efficient way to retrace something rather than the traditional locate.
Okay, I don't think I put the right emphasis on what Jeff was saying. I don't think No, this was not about, nobody's arguing about capturing it while it's exposed or when it's going in. I believe he was talking about existing as-builts. What we call as-builts are awfully fuzzy. They have a lot of unknowns. They're not current. They're not precise. I think that's what Jeff was going about, that sometimes rather than try to just keep tweaking those existing as-builts, sometimes people will proactively go out and, with the better tools, go and create new records. I think that's what.
Oh, that's a good point, and that falls into CDOT's realm as well. I mean, we know we have poor records on some of our stuff, and so we're leveraging the new tools to go out and upgrade our location based on existing records. You know, and I think that's a great point. It would be nice if people would proactively upgrade their records so that the next time they need to provide them, that they are. And so, yeah, that's one of the efforts that we've addressed with our electricians, that we've provided them PointMan, provided them a EM locator and a GNSS antenna, that they are able to go back out and upgrade those records so that they have a better idea.
Well, that's a good point, Gavin, and maybe we end on this, but I think it's important to get this in. So we're actually talking to several 811 centers about leveraging transparent earth and mandating that when the utility company sends a locator out to locate the line, that they use the PointMan software, so that then the one call center can update precisely where that utility line is and not depend on the as-built record, but also provide that information back to the utility owner so they can also update their system of record as well, be it a GIS or a CAD system. So the fact that we're in these discussions gives me confidence that, again, it's just around the corner. It's going to happen. It's just a question of, you know, who steps forward first. And as I mentioned, we're talking to several 811 centers right now about doing that, because that would be like the easiest way to mitigate a lot of these damages, is that when you go out and locate actually where that utility line is, have everyone update their records.
Okay, I have to put a couple of the questions on hold for the afternoon wrap up. But thanks a lot, Paige. That's the important point. The idea that when somebody's out there and is locating it or sees it or the trench is open or whatever, if any opportunity to capture that data and improve the data set, that's something that we that'd be a fantastic goal. Yes. So I got to wrap it up. I got to move to the next session now. We're running a little late. My apologies to Peter Altala.